Good morning, students. This is lecture 3rd of chapter 2nd, class 11th maths. And today we will discuss the topics how to find domain and range of the functions. And we will also discuss the solutions of the questions which I have given you in the previous lectures. First topic is how to find domain and range of the functions. So for this, first of all, we will understand what is the domain of the function and what is the range of the function. So domain is the set of values of x for which fx is defined. Those values of x for which fx is defined, the set of such values are called domain. Range is the set of images fx which we get by putting the values of x in the function f is called range. Range is nothing but the values of fx which we get by putting the values of x in the function. For example, if first is fx is equal to x plus 3. So as we can see, this function is defined for all real values, right? For all real values, fx is defined. So domain is the complete real set. And for different values of x, we will get different values of fx. For different values of x, we will get different values of fx. So range will also be the complete real set. Next is fx is 3x plus 5 upon x square minus 3x plus 2. So in this is a rational function. So for fx to be defined, denominator should not be equal to 0. As this is a rational function, so denominator should not be equal to 0, then only fx will be defined. So the values of x, we will find the values of x for which the function, this is 0, right? If x square minus 3x plus 2 is not equal to 0, then break minus 3x as minus 2x minus x. So we will get x minus 1, x minus 2 is not equal to 0. That is, x should not be equal to 1 and 2 because these are the values where the function x square minus 3x plus 2 will become 0. And what we want, the denominator should not equal to 0. So domain is the complete real set minus these values of x, right? Because x is not equal to 1 and 2. So all real set minus the values 1 and 2 and put these values inside the curly brackets. So this is the domain of the function fx. Range of this function we will not calculate in class 11th. You will study this in higher classes for such functions, right? Now next is fx is equal to root x minus 1. So fx will be defined when the root will be positive. The term inside the root will be positive or 0, then only the function is defined, because negative values inside the root is not defined. So term inside the root should be positive, then only fx will be defined. Therefore term inside the root is x minus 1. It is either equal to 0 or greater than 0. So x is either equal to 1 or greater than 1. Therefore domain will be equal to 1 or greater than 1. So goes up to infinity. As equality is here, so we will put the square bracket, and at infinity obviously round bracket will come. So domain is from 1 to infinity. As fx is what? Root x minus 1. So all the values of fx will be positive. Also at x equal to 1, we will check f1 is 0. So range will be all real positive values, all positive values union 0, because r plus does not include 0. So we will take union with 0, or we can write it as interval like this, 0 to infinity, and 0 is included, therefore square bracket. Now next is fx is equal to 1 upon root x minus 1. Now fx is defined at x minus 1 greater than 0. Why this is so? Because like above, in root x minus 1 is either equal to 0 or greater than 0. But here we will not take equality. Why? Because it is in the denominator, right? It is 1 upon root x minus 1. So first of all, root is here. So the term inside the root will either be equal to 0 or greater than 0. But this root is in the denominator. So this cannot be 0. Therefore x minus 1 is greater than 0. That is x is greater than 1. So domain is from 1 to infinity. And here at 1 also round bracket will come because 1 is not included. X is greater than 1. As 1 is positive, root will also come positive. So this complete fx will assume positive values. Also, this function cannot be 0 for any other value. So ranges are positive, that is from 0 to infinity. 0 is not included. Now next is fx is equal to modulus of x minus 1. This symbol denotes the modulus. For each x belongs to R, fx is defined. You put any values of x, you will get the value of fx. So for each x belongs to R, fx is defined, therefore domain is real value. Fx will assume positive values as this function is a modulus function. So fx will assume the positive values. But at x equal to 1, we can see f of 1 will be 0. Therefore range will also include 0. So range is from 0 to infinity. Clear? Now next is fx is equal to root 9 minus x square. So for fx to be defined, the term inside the root should be either equal to 0 or greater than 0. So 9 minus x square is equal to 0 or greater than 0. How to write this 9 minus x square? This is a square minus b square. So we can write it as a minus b, a plus b equal to greater than 0. So we want this product either equal to 0 or greater than 0. So this product is greater than 0 when either both the terms are positive or both the terms are negative, right? And we will take equality in each case because equality is here. So case first is when 3 minus x and 3 plus x both are equal to greater than 0. Take x that side. क्या आ गया यहाँ से? X is equal to less than 3 and x is equal to greater than minus 3 when you take that 3 that side. So let us draw this in the number line. X is either equal to 3 and less than 3. So at 3 equality is there, so we will draw closed or filled circle and x is equal to 3 or less than 3 and x is equal to minus 3 or greater than minus 3, right? Also and means intersection. These two cases are union because or will come either case 1 or case 2, but in case 1 these two conditions are compulsory. So and that is intersection will come. So we will take the intersection where there is double line, intersection is there. So intersection is from minus 3 to 3, right? Because double lines are from minus 3 to 3. Also we can see in both the lines minus 3 and 3 are included. Now case second, 3 minus x and 3 plus x both less than equal to 0. So take x that side, x is equal to greater than 3. So x is either equal to 3 or greater than 3. And the next is x is equal to less than minus 3. That is either equal to minus 3 or less than minus 3. So as we can see, there is no double line like this, right? Here is no double line, so their intersection is 5. Now domain will be what? Union of both the cases. So union of this with 5 will be the same set. So our domain is minus 3 comma 3. Clear? Now as fx is what? Root 9 minus x square. So fx will assume only positive values. So fx will assume only positive value, but we have to check in this domain what values fx will assume. So at f equal to minus 3 we can see 9 minus x square. See here it is root 9 minus x square. So root 9 minus x is what? Minus 3. So 9 minus minus 3 square, which is 9 minus 9, 0. And this f of minus 3 is equal to f of 3. because when you will put in place of x 3, 3 square is also 9. Now f of minus 2, 9 minus minus 2 whole square. So we will get it as root 5, which is equal to f of 2. Similarly, f of minus 1 you will get as root 8, which is equal to f of 1. Next is f0, root 9 minus 0, root 9, which is 3. So domain is from minus 3 to 3. All the values from minus 3 to 3. So as we can see, at minus 3 f of x is 0, at 3 f of x is 0, then root 5, root 8. So these values are also less than the 3. At f0, the value of fx is 3. So 3 is the highest value which fx will assume, and 0 is the lowest value which fx will assume. So range will be from 0 to 3. Clear? I will suggest you to revise all the examples once again. So your homework is you have to complete questions 2nd and 5th of exercise 2.3 and miscellaneous questions 3rd, 4th, 5th, 6th and 8th to 12th. Okay? So complete your homework carefully. Solutions of the questions which I have given you as homework in the previous lecture. So first, talking about the solutions of exercise 2.2, question number 6. Determine the domain and range of R defined by, the relation is defined like this. We have to tell the domain and range. So relation is what? X plus 5 such that x belongs to the set 0 to 5. So it is very simple. X values are given to you. Put x values, you will get the ordered pairs. At 0, y will be 5, then 1, 1 plus 5 is 6, 2, 7, 3, 8, 4, 9 and then 5, 10. Domain is the set of first elements, so domain will be 0 to 5. Range is the set of second elements, so 5, 6, 7, 8, 9, 10. So range will be 5 to 10. Clear? Question number 8, let A is equal to xyz, B is equal to 1, 2. Find the number of relations from A to B. So as we know, number of relations from A to B is equal to the number of subsets of A cross B. Number of relations is equal to number of subsets of A cross B. So to find number of subsets of A cross B, we will find number of elements in A cross B. So number of elements in A cross B is number of elements in A into number of elements in B, which is 3 into 2, 6. So number of subsets will be 2 raised to the power 6. Clear? So 2 raised to the power 6 relations are there from A to B. Question number 9. Let R be the relation on Z. Z is the set of integers. Defined by R, AB. AB belongs to integer. A minus B is an integer. Find the domain and range of R. So relation is given as AB, where AB belongs to integers and A minus B is an integer. We have to find domain and range. So as we know, difference of any two integer is an integer. You take any two integer, their difference will still be a integer, right? So when any two integer difference is an integer, so A and B can be any integers. So domain is the complete set of integers and range is also the complete set of integers, right? Question number 5th. Let A be the set given as 1, 2, 3, 4, 6. Let R be the relation on A. R is relation defined on A. It is defined as AB, that is those ordered pairs in which A and B both belongs to the set A, and the condition is B is exactly divisible by A. The condition is we have to take those ordered pairs in which the second element is completely divisible by the first element. So first question is write R in roster form. Now the set R will be, first of all let A be as 1. Now A will completely divides B. So 1 divides 1, 1 divides 2, 1 divides 3, 1 divides 4 and 1 divides 6. So all these elements will come. Next, if A is 2, then 2 will divide 2, 2 will divide 4 and 2 will also divide 6, right? Then next, if we take a as 3, so 3 divides 3 and 3 divides 6. Then if we take a as 4, then 4 divides 4. And when we will take a as 6, then 6 divides 6. So these are the elements of the set R. Now the next is find the domain of R. So we know the domain of the relation is the first element of the ordered pairs. So 1, 2 will also be there, 3 will be there, 4 and 6. So the domain will be 1, 2, 3, 4, 6. That is the complete set A. And range, you can also see the range is also 1, 2, 3, 6 and 4 is also there. So the range is also the complete set A. Clear? Now question number 7, write the relation R, which is the ordered pair x comma x cube. X is a prime number less than 10 in roster form. We have to write this set in roster form where x is a prime number less than 10. So the prime numbers less than 10 are 2, 3, 5 and 7. The second element is x cube, 2 cube is 8, 3 cube is 27. Similarly 5 cube is this and 7 cube is this. Questions of exercise 2.3. Question first. Which of the following relations are functions? If it is a function, determine its domain and range. First we have to check that whether the given relations are functions or not, or if they are a function, determine their domain and range. So first is given as 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17, 1. So as we can see, the first element is not repeating, right? First element is not repeating. So each element has the unique image. So it is a function. Here one second element is just only 1. But we are not concerned with the second element. First element should not repeat. 2 has only one image 1. Similarly 5 has only one image 1. All the first element has only unique image, therefore it is a function. Domain, you know, set of first elements, and range is set of second element. So second element is just 1, so range is 1. Now next is 1, 3, 1, 5, 2, 5. This is not a function as 1 has two images. 1 has image 3 also, 1 has image 5 also. When first element repeats, that means first element has more than one image, so it is not a function. Question number 4. TC is given as 9C upon 5 plus 32. Find T0. So for T0, instead of C, we will put 0. So we'll get the answer as 32. Next is value of C when TC is 212. TC is given as this. Now they have given TC is 212. Right, so in place of TC, put 212. Also take 32 that side is equal to 9C by 5. We have to calculate the value of C. So 212 minus 32 is 180. Also take 5 that side. When you solve it, you will get C is equal to 100. Question number 3. It is given a function f is defined by fx is equal to 2x minus 5. Write down values of f of 0 and f of minus 3. So function is already given. We wanted to find the value of f of 0. Now see here, it is x. In place of x in the question, here it is 0. So in place of x, we have to put 0. So f of 0 will be 2 into 0 minus 5. In place of x, just put 0. When you will solve it, you will get the answer as minus 5. Next is f of minus 3. That is, in place of x, we have to put minus 3. When you will put in place of x minus 3, you will get it as 2 into minus 3 minus 5, which is minus 6 minus 5, which is minus 11. The miscellaneous questions. So question number first, the relation f is defined as fx. Fx is what? X square when x is from 0 to 3 and 3x when x is from 3 to 10. And similarly gx is defined to us. First we have to show f is a function. So we will show that this fx is a function. So for all values of x except at x equal to 3, fx assumes only one function. As we can see, at x equal to 0, function will be x square. At x equal to 4 will lie in this interval. Function will be 3x. But we can see at 3, equality is here also. So at 3, fx will assume two function x square and 3x, right? So for all values of x, except at x equal to 3, fx assumes only one function. If fx assumes only one function, so value will be only one. So that is only one image of x. So we just have to check at x equal to 3 if fx has one image or more than one image. So at x equal to 3, fx is x square also and 3x also. But when we put 3 in place of x, we'll get 9 and 9 because 3 into 3 is also 9. So we can see fx assumes two functions but they give the unique image. Therefore f is a function as each x has unique image. Now see the function gx, it is x square and 3x. At 2 we can see gx assumes two functions, right? So for gx at x equal to 2, gx assumes these two functions. g2 will be 4 when gx is x square and g2 will be 6 when gx is 3x. So g is not a function because at x equal to 2 has two images 4 and 6, right? So g is not a function because image is not unique at x equal to 2. So this is what we wanted to show, that f is a function but g is not a function. Now next is question number 10th. Let A be the set 1, 2, 3, 4, B be the set 1, 5, 9, 11, 15, 16 and F is given as 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Are the following true? Give reasons. We have to give reasons for the following statements. First is f is a relation from A to B. So check if either is f is a relation from A to B. So f will be a relation from A to B if f is a subset of A cross B. So we can clearly see 1, 5, 1, 5 will belong to A cross B. 2, 9 will also belongs to A cross B. 3, 1 will belongs to A cross B. Similarly, these two will also belongs to A cross B. So F is a subset of A cross B. Therefore, yes, F is a relation from A to B because F is a subset of A cross B. F is a function from A to B. As no, the answer is no. Why? Since the first element 2 has two images 9 and 11. We can see the first element 2 has 9 and 11, two images. Therefore, it is not a function. Question number 2nd. If fx equal to x square, find f of 1.1 minus f of 1 divided by 1.1 minus 1. So see, we want to find the value of this complete and fx is given us as x square, right? So I want the value of f of 1.1. So f of 1.1 will be 1.1 whole square, which will be 1.21. Similarly, we want the value of f of 1. So f of 1 will be 1 square. In place of x, just put 1. 1 square is now 1. Now we wanted to find the value of this. In place of f of 1.1, write down its value. In place of f1, write down 1. Upon 1.1 minus 1 will be 0.1. This is equal to 0.21 upon 0.1 and this you will get it as, when you solve it, 2.1. Clear? Question number 7th. Let f and g be the functions from R to R. R is the set of real numbers. Be defined respectively by fx is defined as here x plus 1 and gx is defined as 2x minus 3. We have to find the values of f plus g, f minus g and f upon g. So to find the sum of two functions, just add those functions. So fx is x plus 1 plus gx is 2x minus 3. Adding them, you'll get the answer is 3x minus 2. Now f minus g will be the function fx minus the function gx. When you will solve it, x minus 2x will be minus x and plus 1 and minus minus here this becomes plus also. So plus 1 plus 3 will be plus 4. F upon g will be fx upon gx. Also x cannot be equal to 3 by 2. This function, this complete function is not valid when the denominator is equal to 0. Right? So when denominator is equal to 0, the value of x will be 3 upon 2. So x cannot take the value 3 by 2. Also mention this when you will find the function f upon g. Also mention that x cannot be equal to 3 upon 2, because at this value this denominator becomes 0 and the complete function becomes not defined. Clear?